Hello everyone. In this video we're going to go through standard form. We partially used this on your test, and I did show it a little bit in your review from the other day, but here are the general notes. Standard form equations use this formula, ax plus by equals c. And the definition of a standard form equation is this, ax plus by equals c. And in this formula, a is a number that's greater than 0. A has to be greater than 0, or it is okay if a is 0. A and b can't both be 0 at the same time. That's what this says. A and b are not both 0, means that either one of them can be 0, but not at the same time. And a, b, and c are reduced so that there are no common factors. Whenever you're writing this with numbers, you don't want to have like a 3, a 6, and a 9. You would want to reduce it so that it's 1, 2, and 3. If there's anything that's in common to all three of them, you need to reduce it by whatever the common factor is. Some of the things that are good about standard form are that the best way to find x and y intercepts, sorry about that weird P, the best way to find x and y intercepts comes from this form, because you just put 0 for one of them and solve for the other one, which I'll show you in an example in a bit. It is also balanced. If you wanted to solve it for x, that's just 2 steps away. If you wanted to solve it for y, that's only 2 steps away. It's equally balanced to solve for x or y. It models everyday situations like shopping, buying things, or if you're a business, whenever you're stocking up and as you're selling things, both of those variables can be taken into account in a standard form equation. So if you're a business person, you're probably going to use standard form or see the results of a standard form graph. And something that is also good is that because you can use this in business, you can think of the x and y. They don't necessarily have to be inputs and outputs. When you have y equals, it's easy to think you're going to plug in for x and solve for y. But whenever you have standard form, since x and y are both on the same side, that means that those are both going to be inputs. Both pieces of information are going to be used together, and they have to add to make whatever this c is. Some of the things that could be considered cons, it does take time to find the slope. If your goal is to find slope, you're going to have to do a couple steps to find the slope. It's hard to make a table from standard form. Because x and y are on the same side, and a table needs both x's and y's, it could be a little bit weird unless you have a simple situation, or unless you do this last thing, which is, if you change the way you're thinking of your inputs and outputs, that might be hard for some of you, but if you're able to change the way you think of your variables, then making a table with a standard form equation could be pretty easy. And we're going to have some good word problems to go with this, maybe not in today's lesson, but in the next day or so's lesson coming up. Now let's do an example of standard form in graphing. Two x plus 3y equals 5. Let's graph this. If you're going to graph in standard form, then you have to make this goal. When graphing in standard form, the way you do it most efficiently is if you find the x-intercept and the y-intercept. You can graph it a different way, but if your goal is to find the intercepts, that'll give you the ability to graph it very quickly. Let's just do a little bit of reminding that the x-intercept happens whenever you have something for x and 0 for y. The y-intercept happens when you have 0 for x and a number for y. We have 2x plus 3y equal to 5 as our equation. So how about we solve for the y-intercept first? If we're finding the y-intercept, then we're going to put 0 for x. So we'll do 2 times 0 plus 3y equals 5. Alright, so 2 times 0 is 0, plus 3y equals 5. If 2 times 0 is 0, then we don't even care about that. So all we care about is we have 3y equals 5. So all we need to do is divide by 3. Y equals 5 over 3. We divided by 3 on both sides. I didn't show that step, but that's all that we did. We divided by 3. So the intercept here is 0 for x, 5/3 for y. Now let's find the x-intercept. The x-intercept happens when you put 0 for y. So we'll do 2 times x plus 3 times 0 equals to 5. Alright, so 3 times 0 goes away. Nobody cares. It's 0. That leaves you with 2x and 5 still alive. 2 is multiplying x, so we'll divide it to move it. And now we get x is equal to 5/2, or x is equal to 5 over 2, or x is equal to 2.5. We have 5/2 for x, 0 for y. We have 2 points. 2 points is all that you need to make a graph with a line. I know before I said it was 3 points, but that's because you guys are still noobs at making tables and making graphs. So 3 points is going to make your graph better. If you're in standard form though, 2 points is enough, and for any line, 2 points is enough. Okay, before I make my graph, let's just look at these 2 points though. 5 over 2, that's positive, but it's not very big, and 5 over 3, that's also positive, but it's also not very big. So whenever I'm making my graph, I do want it large enough so that I can see it and read it, but I don't need to fit a ton of numbers on here. So I'm going to make this 1, 2, 3, 0, 1, 2, 3. Let's do the x-intercept first. 5/2, which is 2.5, and 0. There's the x-intercept. Now we'll do the y. 0 for x, 5 over 3 for y. Okay, so 5 over 3. 6 over 3 would be the number 2, but this is 5 over 3, so it's a little bit smaller, which means I'm not going to be up at 2. I'm going to be at 1 2/3. And now I will connect these with a line, and we're good. Depending on the situation, the line could stop at those points, or it could go through it. In real life, you don't have infinite numbers, so sometimes you don't go through the axis. In fact, let's just do an example like that of why it would stop.